Even if we are in 2017, we are used to using third-party services. Like, for example, if you use Google a lot, you're used to managing your pictures up in the cloud, or other companies rely on companies like Amazon for spinning up virtual machines, etc. So it's all about consuming third-party services, mainly SaaS platforms. Although we are kind of used to do that, still in 2017 there are companies who don't really believe in the cloud or trusting their data, pushing their data somewhere up in the mysterious magical clouds where they don't have control over. And what I want to talk to you about today is our experience with starting our own SaaS platform, and how for certain customers we have to deploy our deliver our SaaS platform on-prem, so running on the infrastructure of those customers and the pitfalls we encountered, and yeah, our experience around that. So, who am I? Cool, this works. I'm Christhope Vanlancker. I've been working for at least 4 years at Inuits. I'm responsible for the internal operations and also do consulting for external customers. And when we have new colleagues, juniors starting, I mentor them and make sure that they are prepared, are able to function internally, and then eventually, after some time, when they're ready, we can send them off to do consultancy for customers themselves. Normally, it would have been my colleague, Christhope Vanlancker, giving this presentation, but he didn't manage to come, so I'm replacing him and sneakily just replaced his name with my name, so I hope that works fine. So, Inuits, we are an open source company. We are present in a number of countries. We have 2 offices in Belgium, in Ghent and in Antwerp. We have an office in the Netherlands, in Rotterdam, in Kiev, in the Ukraine, and in Czech we have 2 offices, one in Prague and one in Brno. So the way we work, we have one common language, English, which kind of helps communicate with all our different colleagues. Usually on the chat we have a rule: if you write something which is not in English, you need to buy beers. Now, unfortunately, that doesn't actually happen in practice, but when it does, we're always very happy and grateful for that. So as I said, we are primarily a consulting company. We also do development in different languages, mainly PHP, so yeah, Drupal, Symfony, Angular development, also some mobile development for Android and sometimes iOS, but that's not really necessarily iOS. And also system administration, so we go to customers, set up their infrastructure, maintain it, monitor it, automate it, and also make sure that it's high available. And the little notes down there, and some niche SaaS platforms. And I'm going to talk about one of these SaaS platforms, which we built as an example of how we went through that journey and the issues that we stumbled on. So one of these SaaS platforms, so for those who don't know, SaaS is software as a service. So normally what's a SaaS platform? You as a customer, you can either run the application yourself, then you have to maintain it, update it, and those kind of things. Usually you're not interested in that, you're just interested in consuming the service, just using it. It's like, I just want to upload my pictures to the cloud, to Google, and just be able to upload, share them, view them, but you don't want to mess with keeping the servers up to date, those kind of things. So that's the concept of a SaaS platform. One of those, what I want to talk to you about is Mediamosa. So Mediamosa is a digital asset management system. So it's a system where you can upload images, videos, etc., and then do some things with it. So it's kind of like YouTube, but you can also upload documents and do some other kinds of fancy things with it. Transcoding, so if you upload video in MP4, for example, you can choose to make that available in different other formats, and the transcoding happens and all that stuff. Everything is based on open source technology. Yeah, and this is basically how the flow looks like. So you have producers. Producers are just people or ways to ingest, pump data into the system, analyze it, metadata gets created to help index it and search it easily. Then you have collaborators. So collaborators can be, so some practical example, for example, if you use this at the university, you can make some videos of courses available, and then you can have collaborators, for example, teachers who are then going to enrich the data, like add descriptions or add subtitles to it, all those kind of things. And then, of course, you have the audience, the people consuming the data, which you can make available through a front end, so the website or whatever. And they can just download the videos or stream it, all that kind of thing. So the software itself is called MediaMoza, and MediaSalsa is the name of our product, our SaaS platform. So it's the combination of the infrastructure, cloud infrastructure, as you will, running the MediaMoza service. So what does it look like? This is a simplified overview of how it actually looks like internally. So we have the backend, the core of the software, which handles the uploading, the updating, accounting. Also, it triggers, it talks to transcoding servers to start converting formats around. We have front ends. They are optional, because if you want, you can just make use of the backend and then you make your own front end or software which talks to the backend. But what we usually do is also, like, for specific customers, they would like to have, of course, a specific website with the theme of their organization or their university. So custom made front ends which just talk to the same backend. This runs on web servers, so the backends and front ends run on web servers. We have databases, MySQL. We use Solar for indexing. So if you want to allow people to quickly, I want to search a video or I want to search a document, and you don't really know the title, but you know more or less what it's about. Those are text searches, and those are not very optimal in a MySQL database. That's why you can use the database which is more specialized in text searches like Solar, but you can also use Elasticsearch for that. And then we have transcoding servers. Those are nothing more than web servers, but with transcoding software installed on them, like FFmpeg and the backend software. Why do we have separate transcoding servers? Because, of course, if your front ends and backends and your transcoding happen on the same server, and the transcoding happens to be running, you might notice that the website seems slow, and you want to avoid that. That's why you want to have those separately, of course. So, how did we start? How did we, what's the approach that we took? So, we love automation. So, whatever we can automate helps us with consistency. It helps us also with saving time. Like every time we have a new customer, for example, we just need to change a couple of things and everything is automatically set up. What do we use? We use Puppet. Puppet, for people who don't know, Puppet is a configuration management system, just like Chef, SaltStack, or CF Engine. It allows us to do infrastructure as code. What does that mean? It means that your infrastructure, you describe it in code. Code you can automate, code you can review, you put that in a version control, you can test code. Those are all advantages of being able to describe your infrastructure through code. So with Puppet, we set up the infrastructure, the servers, the roles. This machine should be a web server, this machine should be a database server, this machine should be a transcoding server. So Puppet helps us to set it up, and we use mcollective to orchestrate the things. By orchestrate, I mean mcollective allows us to, for example, whenever we need to deploy a new version of the software, we use mcollective to send a signal to all the relevant servers. Hey, there's a new update of the software. Orchestrate the release of it. mcollective also helps with other nice things, like for example querying. If there's an exploit for the web servers, we can very quickly use mcollective to query our infrastructure. Hey, where is this version of this software installed? And then you get a nice inventory of all the machines where that particular software is installed on with a particular version, and then we can figure out which machines need patching, etc. We also use continuous delivery. So for people who don't really know what the difference is, so with continuous delivery, it's the ability to make changes of any kind, like new features, configuration changes, bug fixes and experiments, roll them out into production or in the hands of users in a safe and quick fashion. So it also means that you're able to prove that, hey, this build, this version of my change comes exactly from this source that I wrote. Then the next step is continuous deployment. Continuous deployment means that every change passes automated tests are deployed in production automatically. And the important keyword is, of course, testing. What you want is that you're able to deploy to production very quickly, many times a day. Usually that's very hard for companies because it needs to be done right, of course. So we apply the concepts of CD to our Puppet code. So every time we make a change that affects the infrastructure, it gets deployed to development. In the development environment, we do some more tests. Once we are okay with the changes in development, we take a kind of snapshot of that code and we promote that approved change into an acceptancy environment, and then later on in production. The triggering of the deployments, so the promotion of the code to acceptancy and production is manual. So that actually means that it's not really continuous deployment. We're doing continuous delivery, but not continuous deployment, because continuous deployment means that you can't have a manual step to promote stuff to production. Now, of course, you can ask yourself, like, okay, we have different people working on the same thing. If I make a change and it's not ready yet, but another colleague also makes some changes and he wants to push to production, that kind of blocks itself. You block each other. How can you avoid that? With feature flags. Now, feature flags is a fancy word for an if-else construct. So, like, for example, I'm working on a new feature, but it's not ready yet. I'm going to make sure that that part of my code is only executed specifically when I add a boolean. So that allows for my code, which it's not ready yet, to still get that into production, but it wouldn't have any effect unless I specifically enable that feature, which I will enable when I'm sure it's working. But of course, you don't really need feature flags if you have very detailed and very good testing. And we do the same for the application codes, so also passes through integration tests. But here, the deployment to production is a business decision. Usually, you have agreements with like. Yeah, you want to prepare some campaign like, hey, you want to announce to your customers, yeah, we have these new features, they're going to be rolled out at a specific date. You don't want your infrastructure to wait for that in order to promote all that and then test everything at the last time. No, you need to be able to do those things more frequently. So testing, how do testing happen? Well, first of all, developers, they test on their machine, but you need to have a certain workflow where every developer works in the same environment. Like what you want to avoid is that one developer tests on his laptop with specific libraries, specific versions of applications on his laptop, and then yeah, it works here, and then pushes it, oh, but it doesn't work in development. We want to avoid that, and we do that by having not the developers install updates themselves, but we use Jenkins to automate that. So it's all the code that is checked out, all the codes, the testing and everything runs on Jenkins, and that gets then deployed to the development environment. And we can use Vagrant also. It's a tool to spawn up VMs with specific versions of software, so we can make sure that developers are all testing and developing within the same consistent system. We use Git for version control, so every change that we make on the application level, but also in the code that we use to manage and describe our infrastructure, we put in version control, so we know exactly who makes changes when. We can audit them, or we can also roll back some code changes which afterwards turned out not to work so great. We also prefer small changes, because small changes are better identifiable, and also it's easier to modify them afterwards, rather than working for a whole month on one or on different features, then deploying them. Then if it doesn't work, like, okay, then you have to go through a huge code base of changes to figure out where the problem was. So small changes are always better. For the infrastructure code, also we also put that in Git, as I said. Here, I hope people here know Puppet or some concept. Okay, so in Puppet you can describe your infrastructure, but you can also put your data into that. And putting your data inside Puppet actually means hard coding it, which doesn't allow you to be very flexible. So what we do is we describe our infrastructure, how it looks like in Puppet, and the data, passwords for the databases, passwords for this vhost, those kind of stuff, that's data. We separate that from the code, and the system to query which variables, which data needs to be configured, that is stored in here. We also leverage the packaging system of the OS, so we generate RPMs, or you can also use Debian files if you're using Debian. What is the advantage? Well, what's the advantage that you get from using packaging? You get auditing, so you don't use, we don't deploy tarballs, because RPMs allows us to have consistency. So only the files which are described in the RPM package gets deployed. If you are updating something, the files which were previously part of the previous version gets removed, and the ones in the new RPM gets deployed. So you have that consistency. Also, auditing is very important. If RPMs and deb files, they maintain hashes of all the files that are part of them. So if you suspect that there might have been some tampering with the system, you can actually ask your operating system, your packaging system, hey, has this file been tampered with? Has this file been modified with regards to the original one present in the package? And then you can, that helps to identify those kind of problems. And it's also super easy to automate software installation with your configuration management tool. You just say in Puppet package HTTPD for the web server, ensure presence, or whatever software you have, and your configuration management tool will just install the package which is present in the repository. No need to describe some fancy things like wget from somewhere or whatever. Configuration does not belong in the package. What you want to avoid is deploying your software with hard-coded information. To me personally, honestly, I think the only exception to that is if you want to add some sane default as part of the software that you deploy, just enough to get it running, but do not include already the connection strings or the specific stuff for the platform, for the environment where you're deploying on. You just let your configuration management tool take care of that. So pipeline. So we use Jenkins. Jenkins is a system to allow to automate different kind of jobs. And by jobs, I mean the most abstract sense of the word, like do some things. What do we use it for? For example, to fetch the source code from the Git repository, do some testing on it, different jobs do tests, and there's a job to package it, and then there are some other jobs too that handle the deploying of the software. Pipeline, so what is pipeline? It's just a fancy word for these jobs, a collection of jobs which work on the same code base. From a developer's perspective, what does it look like? They start developing code, making changes, they push their changes in the repository, and then the system automatically starts picking that up, doing testing, etc., packaging, deploying. And the only thing that developers should care about is that and getting an email if it's worked or not. So this is an example of what a pipeline looks like. So these are the image, and what's underneath it are two separate things actually, but it boils down to the same. So you have a first stage. The first stage pulls in the code. There are some tests running. We use FPM to package. FPM is a tool that allows us to easily generate packages. So how many of you have already tried packaging themselves with spec files or do it in Debian? Okay, so the people who have already done it, you know that it can take some time in order to do it properly, because you need to follow the guidelines and everything. With FPM, which is short for effing package management, is just a wrapper around those tools which allows you to just say, hey, I have a directory, I just want an RPM or a Debian or a deb file. Nothing else. It takes care of everything else. It takes care of all the specific things that you ought to know in order to package. We're not interested into that. We just want an RPM package or a Debian package to be able to deploy quickly. And then we use mcollective to signal to the environment that, hey, there's a new version, fetch it and install it. And then we also use mcollective to continue promoting the changes to the next environments. So the nice thing is we use the same pipelines, the same tools, the same patterns. Both the developers use them, and the operational people use the same. So we collaborate, we use the same tools, so we are everyone is aware of how everyone is working. So measurement, also very important. So we have all these servers running. What do? We use LogStash to collect the logs. The application generates logs, how it works. Apache generates logs. The system itself also generates logs. We use LogStash. LogStash allows you to do some nice transformations based on those. Like for example, if there's an IP address present in one of the logs, LogStash can enrich that information by, for example, doing a geo lookup. So transform that IP address into a specific country, specific city, for example, which is nice to afterwards be able to visualize that, like where is my traffic coming from? Oh, we apparently have a lot of people in Belgium using it, or we have visitors from the US, that kind of stuff. We use Elasticsearch Kibana, well, LogStash, that's part of the ELK stack. So LogStash, you send your logs to LogStash. Elasticsearch is going to index those logs to make it easier to search very fast for those logs. And Kibana is just generates dashboards in order to better visualize that information. So you can make dashboards based on the information you really want to see, like for example your visitors, or how many failed attempts there have been to log into your system, that kind of stuff. StatsD and Graphite, we use StatsD and Graphite to collect metrics. So metrics like CPU usage, loads, memory usage, how many users are logged into the platform, anything, all those kind of metrics we collect and visualize. For monitoring we use Isinga, but there are also other tools out there like Zabbix or Prometheus also, but we mainly use Isinga because we also automated our monitoring platform through it. So every time we deploy a new vhost, it gets automatically collected in Isinga and is monitored. Databases get monitored. Connections from the backend and frontend to the database is also monitored, so that's also important. Cron jobs, if they have run, if they haven't alert if they haven't run in a while, and those kind of things. Yeah, so here's an example of what those metrics look like in GDash, for example. But nowadays you also have Grafana, which is a better way to generate dashboards to visualize all these metrics. So transcoding metrics, number of accounts, those kind of things. So sharing is also a big important part of our company culture. MediaMoza is open source, so if you want, you can download it yourself, set it up. If you find bugs, you can contribute back. There's also a lot of Puppet code around modules that you can use to basically build your own SaaS platform as well. The only thing we don't share is our passwords, of course. Unless, of course, by accident, in which case, please let us know and we'll remove that as soon as possible. But normally shouldn't be anything sensitive there. So, finally, to the gist of the talk. We initially had 2 instances. So we started, we needed to install it somewhere. We had an initial investor, an academic investor. So that's nice, we deploy it there, we start setting up the virtual machines, and we also have a separate commercial platform for commercial stuff that doesn't fit, can't be hosted at the university. Nowadays, unfortunately, we have 2 academic instances, 1 commercial SaaS platform, and 2 on-prem deployments. How does that happen? So, when you start with your startup, for example, and you have your initial setup, you're looking for investors, you're looking for customers, you onboard them, and that's really nice. But then you can have these big customers, which very often have public funding, so they have a lot of money, And it's very tempting. Like, you're a startup, you're just beginning. You could really use those fundings, and it's very persuasive to just, okay, make some exceptions for this customer, no problem, we're going to deploy on your infrastructure. But there are some implications to that. So some of these customers, the reason why they want to run that SaaS or SaaS platform on their infrastructure is either because they want to feel like they own the data, they have control over the data that they put into it. Or, for example, they recently made a very big acquisition in storage, and it would be a shame for them to not use it. So it's either, from a business standpoint, you either say no to that and say goodbye to a lot of, or you say, okay, no problem, we're going to deploy it on your environment. So, initially, we said, okay, no problem, we already automated everything, we use infrastructure as code, the ways of deploying is automated, so it should be trivial, right, to just deploy on premises at a customer? Wrong. After a while, you realize that actually your automation is biased. Sure, you've automated it, but for your infrastructure, for your environment where you have full control over, and you're able to freely, like if you want to expand some things, you can do that. It's a lot harder to do that with a customer. So also, yeah, our Puppet code has certain expectations, our monitoring has certain expectations, like it's able to connect to everything it's supposed to connect. Our metrics go through a certain path over the network to our metric collection system. The machines, they fetch their packages from our repositories, and of course our Jenkins expects to have access to those servers for deploying. But the problem is, at these on-prem sites, you usually encounter different things, like it's a different hypervisor. So we are used to deploying on KVM, for example, and at customers, it's very often you can encounter VMware platforms. Their networking topology is different. They might have their own DMZ implementation. So all these things, and yeah, like in the rest of the slide, like if you have control over your own infrastructure, you can decide when to reboot or to grow a VM. When you're running that on-prem at the customer, you need to talk to them, you don't have access to the platform to reboot and those kind of things. And just a quick question, how many of you have experience with Amazon AWS or Google Cloud Computing? Have you ever tried asking them if they are willing to install your own custom script to monitor their hypervisors? Why haven't you? So either you don't, if you ask Google like, hey, I think your service is a bit slow, do you mind installing this monitoring script on your system so that we can be alerted? Like, either you don't get an answer or you're being laughed at. But ironically, those kind of customers do ask those kind of questions to you because it's running on their platform, so they kind of feel like, well, we own it. And yeah, and you often have to say no to that. Yeah, well, you also have customers who ask to have accounts on those systems, and it's kind of like a warranty. You provide the SaaS platform, you have control over it. It just happens to run on their infrastructure, but what you want to avoid is having the customer access to your platform, because then it's kind of like voiding your warranty. Like if something happens, you don't want to get into a conversation with your customer where you're blaming each other if it's something breaks, like, yeah, but no, it's your fault. Yeah, no, but you logged in and you touched this. That kind of conversation you don't want to have with your customers. What's also very difficult, what's also very hard is you automate things. You don't want variance. But then you have customers who like, yeah, we tried this, but it doesn't work for us. We would like to use a different search indexing software, or we would like to have some other image rendering thing. It's kind of difficult because these customers are willing to pay for it, but it's a variant, and it doesn't really. When you have a SaaS platform, the model is you want to give a fixed price per customer, and of course that scales within your infrastructure. But if you ask use the same price model for an on-prem customer, those costs, your costs are actually higher to maintain that, because it's cheap to maintain everything within the same infrastructure, things that you have control over, but you don't have that kind of control at the on-prem side. So things can get a bit out of hand, and there's not always the same expectations there. So we've got ourselves into a situation where deploying isn't really our decision anymore. We need to talk to the customer and ask them when we can make some changes. Like, for example, scaling. If you have MySQL servers and you need to scale them, or you want to improve that, you need to do those improvements everywhere. So not just on your infrastructure, but also on-prem at the customer, because otherwise, if those are different, those are two separate things that you need to maintain. That adds to the cost of maintaining those platforms. Even security fixes, really horrible. So yeah, instead of an effort to run 5 stacks on your own infrastructure within your team, smaller than running one additional stack on-prem at customer. And also, yeah, sometimes your methodology doesn't fit with how things are managed at the customer. But hey, it could have been worse. We only use open source software, so we have control over everything that's installed. Imagine dealing with proprietary software with deals in licenses that you have to pay X amount of money per license or per certain things, and what if you're not able to do that for that particular customer? Then you have, again, a variation, and variations adds up in the cost of operating. So the advice that I would give to people who are working on that and are thinking about doing those kinds of installations for on-prem for customers, try to say no. It's not a technical issue, it's not a technical problem, it's more of a sales problem. Because as a startup, you need that, you can use the money that you get, but sometimes you have to make a trade-off. Like, okay, sure, you're getting all that money, but it can end up costing you a lot more along the way and makes managing the infrastructure a lot more hard. So, yeah. Thank you for listening. If you have any questions, you're welcome. Oh, we seem to have finished right on time, so cool. I think we have maybe a couple of minutes for some questions if there are any in the room.
So you mentioned both DEPs and RPMs. So do you use Fedora or Debian or both?
We standardized on CentOS. In the very beginning, we had all servers were running CentOS, but the web servers running Debian, because at the time FFmpeg, the versions of FFmpeg were easily available for Debian. But after a while, we refactored to remove those Debian machines because you need to automate it. You kind of do double the effort automating both CentOS and Debian. So after a while, we replaced the Debian machine with CentOS machine, so we just need to concentrate on one code base.
Don't you have problem with old versions on CentOS?
Pardon?
don't you have a problem with old software versions with stable CentOS?
Yes and no. Well, it's actually not a very complicated setup, and usually the software that we need we can either find in ePerl repositories or somewhere else, or we can compile it ourselves. But if we compile it ourselves, we need to make sure that those builds are reproducible and automated. So, for example, I automated the building of FFmpeg with all the transcoding features in a Docker file, and it's in Jenkins. So every time someone needs to change that, you just make some changes, press, and compiles, and you get an RPM which you can then install on the various servers. Yeah. I think if you have any further questions, you can find me somewhere around. So thank you for listening, everyone.